So in this next video, this video here, we're going to be actually talking again about displacement and distance and velocity. And my concern is that it looks radically different from the first video you saw, where it was very touchy-feely. I'd, for example, I'd draw like a little point, like this, and we'd kind of travel, and we'd call this an X initial, and this would be an X final, a position final. And then we'd say, well, there's this thing called displacement, which mathematically is written like this, delta x, and that's x final minus x initial. And again, you read this as delta x. And what this means is this is the way we write displacement. I don't want to write the word displacement every single time, so I'm going to start writing delta x from now on, so get used to that. So it's written in red, memorize it, it's what I'm going to use forever. So when you come to class and you're not sure what this is, get this memorized, watch the video again and again. So this is displacement. It's x final minus x initial, or x naught. And again, we kind of do this touchy-feely thing of, well, we travel along a path, we get to this point, to get displacement, we take this and subtract. Now what we're going to do is we're going to take this idea and we're going to do it with graphs. And I'm going to urge you here just to kind of remain calm and realize we're going to be doing the same thing. So I'm really going to look at final position, initial position, and subtract. And we're going to be talking now about kind of long-term motion where we're going from various different points along a graph. Like we go here, forwards, then we go backwards, then forwards again, and then we just stop. And that's how we record our motion. So what we're going to talk about is this thing called average velocity. And let's define it this way. It is your total displacement divided by your total time. And your average distance is going to be your total distance over your total time. And I'm really going to do, and I just want to put this out here right now, this real definition that we see is going to be our first in-class example when you guys come into lecture tomorrow. And in fact, what we're going to do is we're going to look at the motion of the object from 0, time equals 0, to time equals 16. This we're going to actually do in class. Okay. Now, today, on this lecture right now, we're going to focus on something a little bit easier. We're actually going to go for the first one from 0 to 2 seconds. And then what I'm going to have you do from homework is you're going to go from 2 seconds to 8 seconds for the Google Docs homework. Okay, which is why you've got actually 2 pages in your notes. You're going to work that out on your own. So we want to know, what is the displacement of the car from 0 to 2 seconds? And again, I gave you this example here. This is initial position, this is what displacement is. So what do we actually do? Well, to get the displacement from 0 to 2 seconds, I need to know x final minus x initial. That's all it is. So what I'm going to do is this. I'm going to go straight to my graph and I'm going to say, okay, at 2 seconds, what is my displacement? I go and I read it on the graph right here and I realize, oh, wait a minute. At 2 seconds, I'm at 8 meters. And then I say, well, what's my initial position? Well, at time equals 0, I'm actually at the origin. So that's 0. So I say my displacement is 8 meters. Now, in the last lecture, I also told you that displacement has to have a direction. So what I'm going to say is this. Since I'm at 8 and I'm above the origin, I'm actually going to say that this is 8 meters in front of. And that's my way of saying positive. So I am 8 meters away from the origin. Now, if I said, what is the distance I've traveled? What I would say is this. I've gone from 0 all the way up to 8 meters. And therefore, my distance is going to be 8 meters total traveled. So if you ask me then, what is the average velocity of the car from 0 to 2 seconds? I'm going to use this definition again, my displacement over my time. So that's going to be 8 meters from this thing in front of. So positive 8 meters. Okay. You also get that because the slope's positive. Okay. divided by the time, which is 2 meters. So I'm going to end up getting 2 seconds. So I get 4 meters per second positive. Okay. Now you've asked me what the average speed is. I traveled 8 meters total divided by the 2 seconds, and I get 4 meters per second. So in this case, my speed and velocity happen to be the same. That's not always going to be the case. And when we do the example in class, you'll see that that's actually not true. Now, for the next problem, I'm going to actually get you started. So we go here. It's the same thing. So again, we want to know what's going on from 2 seconds all the way to 8 seconds here. So let's get the displacement. So again, I need to go, this is x final here, and you know what, this is a lousy color. I apologize. Just do it in black. So I'm here, so my final position, I read it off the graph, and that's 0. And my initial position here is 8. So my displacement is going to be then, I get x final minus x initial, which is going to be 0 minus 8, which is negative 8 meters. In other words, I travel, another way to say it is 8 meters backwards. I went towards the origin, which you remember from the Buggy lab. Then I say, what is the distance the car travels from 2 to 8 seconds? Here, I travel a total distance of 8 meters. Okay, using the same idea. Okay, now that's really here they happen to be the same. Again, the example in class they won't be. So if you ask me what is the average velocity from 2 to 8 seconds, I would take my displacement divided by my time, and that's going to be 8 meters divided by negative 8 meters divided by 6 seconds. So that's negative 1.33 meters per second. So my velocity is backwards. So I'd say 1.33 meters per second backwards. Either one of these is fine on the exam. I would accept both. Okay. Now for the multiple choice, they'll give you either in this form or that form. You're going to know. So we say, what is the average speed of the car from 2 to 8 seconds? That's just going to work out to be 1.33 meters per second. So actually, it looks like I did this one for you, and that's fine. What we'll do is we'll actually catch up next time in lecture, and we'll do a tougher example in class, and we'll give you plenty of practice then.